Here is a MIG wire feed drive motor from a large commercial MIG welder. It's a 110 volt DC motor, or anywhere, variable speed up to that, I guess. Here is a box that contains a controller for a motor like that one that I built, and inside it is this controller that came from Surplus Center probably 20 years ago or so. They were probably 20 bucks a piece for those controllers. They were takeouts from something, I think a treadmill. Here are the instructions that came with the motor. And a sort of a schematic of the hooking up the thing. I think this is probably the same information, but with the Surplus Center heading on it. Note the part number that they gave it at the time. Here is a document that came, it's a partial document that came from someplace, where some guy is telling somebody else what worked and what didn't. I think this thing had some kind of a the controller had some sort of a soft start feature. And I'm trying to remember whether I followed one of these directions or not to make a change to sort of defeat that. If I had to start someplace, I vaguely remember needing to install or replace a 2N2222 transistor. I don't know if that was to defeat the soft start feature or because it went bad or whatever. It's been so long. Here's the face of the control panel that I built, and there's a foot switch here, and again the motor here, and a power cord that just goes to 120 volts here. But the way the thing is supposed to work is you can make the motor go clockwise or counterclockwise. Well, okay, to start again, this turns the power on and off to the whole system. This controls the direction that it goes. In this switch in the drive on position, the motor just runs from the potentiometer here and the on-off switch. In the down position, the foot switch controls when the motor starts and stops. It's just a, what is it, 8 by 8 by 4 inch box that you buy at just about any store like Home Depot or Menards or what have you, that sells the electrical components. I did a little research on the thing. I built it like, what, 20-30 years ago, and it sat in a box until today, which is April of 2023. And I just wanted to get some idea of how fast the motor goes. So this potentiometer goes from 0 to 100, and what I found so far is the motor only works in the range of 50 to 100 currently. I could change that potentiometer value so it would have the full range. At this point, at any rate, the motor itself, at 3 different settings, at a pot setting of 50, it goes 8 turns in 20 seconds. At a pot setting of 70, it goes 18 turns at 20 seconds. And at a pot setting of 90, it goes 35 turns in 20 seconds. So when I add that up to get to a minute, with the pot set in the middle, it goes 24 RPMs. With the pot set at 70%, it goes at 54 RPMs. And with the pot set at 90%, it goes 105 RPMs, there or thereabouts. And the reason I need to know that is simply so that I know how much reduction a person would have to do to drive a welding positioner table. This is a welding positioning table, or a rotary welding positioning table that I built 20 years ago or so for my son Rick to use in welding on aluminum bogie wheels for the old Cushman Tracksters. There was a hub on the wheels that protected the bearings that would wear away when the bearings went bad, and we just came up with this table in order to be able to fixture a new ring that we would weld on, and then be able to, you know, just rotate the ring at a constant speed, and with a MIG welder set up to weld aluminum with a spool gun, weld on these new hubs. Okay, so the shaft that's sticking out there could simply have a table bolted to it, you know, like an 8 or 10 inch diameter table, and that would be just fine. Okay, at any rate, so it's like 18 plus inches this way and probably a foot this way. Right now it's designed to sit at a 45-degree angle on a table, and the main feature of the whole thing is this device right here, which consists of two large carbon blocks, one on either side of the shaft, that are drilled out to rub on the shaft, and then this metal clamp here is springy, so that is the commutator, if you will, to transfer the ground clamp, which you just clamp on here, to the shaft. And as you can see, that just goes around. I mean, well, it sits still while the shaft is driven. I never did hook up a motor to it, because at that time the operator just simply turned the disc that was screwed on here as needed to do the thing. I put this plate on the bottom. That was another way to attach the ground clamp, and so you could probably turn it 180 degrees and then stop and relocate the clamp and turn it 180 degrees. But this commutator mechanism worked a lot better. Okay. The issue is that I never did motorize it, and that's why I built a motor controller that we would hook up to it. The issue is that this thing needs to go probably a maximum speed of maybe 1 revolution a minute, or 2 or 3 or something like that, but it needs to go down to probably something like maybe a 1/4 of a revolution a minute. And so even if I were to use a pretty low speed motor, I would have to gear it down a bunch more, and I just never got that far. Okay, and so that's where that is today. Okay, here's a short demonstration of how it works. I have the control set at 0, the drive set to on, so this switch would control whether the motor works or not. It's set to on. I turn the power on, little light comes on, nothing happens. I turn this up to 50, and notice a little delay, and then the motor goes. Okay, I turn it down, motor stops. That was counterclockwise. Now I turn the switch to clockwise, turn the motor back up to 50, little delay, motor starts and it goes clockwise. I'll turn it up to 70 just to get a little more speed. There the motor goes. Now I turn the switch, the drive switch to the foot switch position. Motor stops. Push the foot switch. Nothing happened. Notice that I had to start over again, sort of. I turned the pot down and then pushed the switch and pushed the foot switch. Okay. So the pot's at 0. I push the foot switch. I turn the pot to 60. Little delay and it starts up. Off the foot switch, it stops. On the foot switch, it goes again. Off the foot switch, it stops. Don't ask me why it did that after 3 times. But now I turn the pot back down to 0, push the switch, foot switch, turn that up to 60, and it starts again. Stop, start, stop, start, stop, start. Didn't start. I don't know if that was 3 times. Let's try that again. Hold the switch down, turn this up to 60, it starts. And it's slowly coming up to speed, notice. Now it's a constant speed. So if I turn the drive on, so the foot switch is disabled, now what? I turn this pot to 0, turn it back up to 70, and it has that slow start feature. I'll turn it back to the foot switch and back to on again. Starts again, that's once, 2, and the 3rd time it didn't go again. So there's something in there that is, after 3 tries it doesn't work. So I still got to work on that, I guess. So let's just leave the drive on. Let's leave the pot at 70, turn the main switch off, and then just turn this main switch back on again. Nothing. Turn the pot to 0, turn the switch to on, turn it back to 70. So obviously there's still got to be something done. That's 1. It didn't even work the 2nd time then. So some capacitor's charging up in there someplace. If I turn the pot to 0, leaving it on, back up to 70, it goes. Okay. Back up to 70, it goes. You can hear the hum after it stops when the voltage is too low. Okay, so it always works if I just turn the pot up and down. Or at least I know that much. All right, so it needs some work yet. Okay. So here is a DC motor controller that I bought from Surplus Center many years ago. It is connected to this treadmill motor. Via this potentiometer. And with this V-belt, it was intended to drive a grain grinding machine, which I did do, slowing the drive down to about 80 RPM with this large V-pulley. And it works. Son of a gun. Maybe I just need to replace the controller in my Welding Positioner box with this one. This one I must have modified. This is all 120 volts AC being converted to 120 volts DC or thereabouts for this treadmill motor, by the way. And I think this treadmill motor is rated at DC, 6.2 amps, 2 horsepower it says. It's a pretty beefy motor. Anyway, that's what that is.